Polygon below represents a regular hexagon. So here we have this polygon, which is a regular hexagon. And they says calculate the size of the angle X. Now angle X is an interior angle of this hexagon. And so in order to figure out the size of this interior angle, what we're gonna do is we're gonna use this formula. And the formula states that the interior angle is equal to 180 multiplied by n minus 2 all over n. Now, what is n? Well, n is the number of sides. And since this is a hexagon, the number of sides is 6. And we can count it. This is 1, 2, 3, 4, 5, and 6. So this regular hexagon has 6 sides. And so for n, we're going to put 6. And so what we have is 180, open bracket, 6 minus 2, close bracket, all over 6, because n is 6, right? Now we say 6 minus 2, and 6 minus 2 is definitely 4. So we have 180 multiplied by 4 all over 6. And 180 multiplied by 4 is 720. And we have to divide that by 6. So we have 720 divided by 6, and 720 divided by 6 is 120. So that means that the interior angle of this regular hexagon is 120 degrees. And so that means that the size of angle X is 120 degrees. And so that is the size of angle X, 120 degrees, the size of the interior angle of this regular polygon. Next, we have to determine the size of angle Y, and here is angle Y, all right? Now, in order to do this, we are going to use diagonals. And so the rule states that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3, where n is the number of sides. And so that means that if we want to determine how many diagonals, right, that can come from one vertex of this regular hexagon, we have to use this formula n minus 3. And each vertex of the hexagon has 6 minus 3 because n is 6, because the number of sides is 6. So each vertex of the hexagon has 6 minus 3, which equals to 3 diagonals. And so that means that at each vertex, we can draw 3 diagonals. And so if we have this vertex right here, we draw 1, 2, 3 diagonals. And that's the amount of diagonals that we can draw at this particular vertex. And we could do that at each vertex of this regular hexagon. Now, we need to determine what is the size, or what is the measure of each of these little spaces, right? So how much do they measure? So we know that the full thing, right, is going to be 120 degrees because that's going to be an interior angle. But how many spaces do we have? We have 1, 2, 3, 4 spaces. So in order to figure out what is the size of each of those little spaces, we have to take 120 and divide it with 4. So we have 120 divided by 4. Again, we have 120 divided by 4, which equals to 30. And so that's what we have. So that means that each one of these little spaces is equal to 30 degrees. So this is 30, this is 30, this is 30, and this is 30. And let's look at Y. Well, Y only accounts for 2 of these spaces, right? So Y only accounts for 2 of these spaces. And so that means that Y is going to be 30 plus 30, or Y equals to 2 times 30. Now, what is 2 times 30? Well, 2 times 30 is 60. And so that is the value of Y. Y is going to be 2 times 30, which is 60. And so the size of Y is 60 degrees because it only accounts for 2 of these spaces, and we know that each of these spaces is 30 degrees. Next, we have to determine the size of angle Z, and Z is this particular angle right here, and we're going to use diagonals to determine this as well. Remember from this rule, we know that each vertex of the hexagon has 3 diagonals. And so we come to this particular vertex and we're able to draw 3 diagonals, all right? 3 diagonals. And we know that each one of these little spaces right here is 30 degrees, all right? And we know that because the full thing is an interior angle, and that's 120. And if we take 120 and divide it by 4, because there's 1, 2, 3, 4 spaces, we get 30 degrees. So each of these little spaces is 30 degrees. Now angle Z accounts for how many of these spaces? 1, 2, 3 of these spaces. So that means that angle Z is equal to 3 times 30, and 3 times 30 is definitely 90. And so that means that angle Z is at 90 degrees, and that's the size of angle Z, 90 degrees. And that's our answer to this question.